The bottom line is this. The labels on the bottle say 250. The question is, I'm not interested in where 95% of my bottles lie or 98% of my bottles lie. What I really want to know is, can I send these bottles out? They say 250. Okay. Now I have some evidence that we do not have 250 in that bottle, right? I have some evidence that the bottles contain less than 250 because I got a sample mean of 248. So I have some evidence that these labels are incorrect. The question is this evidence statistically significant? Is this difference between the sample mean is 248 and a target value, and my target, which in this case is 250, right? So is this difference between my sample mean of 248 and my target value of 250, is this difference statistically significant? Now, when we did probabilities, remember we said this is why we did probabilities, because we wanted to get to statistical significance. We wanted to get into those tables for you to do this. So what we're going to do this week is we're going to learn how to test the difference between two things to see if they are significantly different. Okay? So that's what we're going to learn today, how to test the difference between two things to see if it is statistically significant. If you listen on the television and they have those commercials for the drugs, they never tell you what the drugs are for, right? They just say, take this and everybody's happy, and they swinging outside and the sun is shining, and you don't know what the drug is for, and they say, ask your doctor about it, and you're like, I'm not asking my doctor, I don't know what that's for. But anyway, ask your doctor for it. But everybody's happy, and everybody's skinny, and everybody's going to have a great life, right? So whatever the drug is, it's really good. Okay, but if you listen at the end, they'll say, side effects may include, or side effects include, right? If you listen to the difference, there's an important difference. If they say side effects may include, at least one person had that side effect. Okay? If they say side effects include, the difference is statistically significant. A significant number, a statistically significant number of people had that side effect. Okay? So the difference, if you listen to it and they say side effects may, and side effects versus side effects include, the difference is statistical significance. Okay? So sometimes you want things to be significantly different. For instance, if I did, this, came up with this great weight loss program, right? And people who took my diet, I did a control group, they did whatever they wanted to try to lose weight. My people used my diet. And, these people lost 10 pounds and my people lost 20 pounds. Okay? I want the difference to be statistically significant, right? I want my people to have lost a statistically significant amount more in weight, right? Sometimes you don't want it to be statistically significant. In this case, what do I want? I don't want it to be statistically, right? I want it to be, no, that's not statistically, right? So sometimes you want it to be significant and sometimes you don't. It depends on the context. But what we're going to do today is we're going to teach a way to measure statistical significance, and then you have to interpret whether you like it or not. But that's the same text, okay? So here's kind of the notion. We've got two things we're looking at the difference between. We're looking at the difference between a mean and a target value, okay? A mean and a target value. Now, we're going to use the same kind of table that we've used before to help us run the test. What we're going to do is we're going to come up with a calculated value. We're going to use a formula I'll show you here in a minute, and we're going to come up with a calculated value that sort of summarizes all the evidence from the sample. Okay? So it's going to include the sample mean, the standard deviation, the number of observations, it's going to include all that stuff. And it's going to be a value that we calculate that summarizes the evidence we have in the sample that these two are different. Okay? So we've got to come up with this calculated value, this number we come up with is the evidence from the sample that these two are different, right? And then we need to compare that to something to know whether it's big enough or not, to know if we pass the test or not. It's like if I said to you, you've got to get 90% to get an A in the class. You'd then compare your score to the 90%, right? Right? Okay. So what you have to do is compare what you got to some standard. Okay? The standard will come from a table value. The table value is the standard to determine if the difference is statistically significant. So we're going to have a table value that's going to be this. So we're going to have a calculated value, and we're going to compare it to a table value. And the table value is the standard to determine whether or not this difference we've observed is statistically significant or not. Okay? It's just a test, just like any test. There's something you have to do to pass the test. If you come up with a number that's bigger, it is significant, right? If you come up with a number that's smaller, it's not. Just like if you said you have to have 90% to pass, if you get 92, yeah. If you get 93, if you get 83, no, right? So we're going to see if this guy's bigger than this guy or not. It's sort of like a scale. My great artistic ability, which you know is lacking, okay? And we're weighing the evidence, okay? Right? Here's the evidence from the sample on this side. Here's the amount we have to come up with. If we have 10 pounds of evidence here and only 5 here, yeah, it's significant, right? If we have 2 pounds here and we're supposed to come up with 10, no, it's not, right? So if the critical value, or the calculated value, is bigger than the table value, it is statistically significant. Okay. So if your calculated value is bigger than the value of the table, it is, whatever you're looking at, is statistically significant. You pass the test, just like anything else. It has to be big enough to be significant, okay? All right? Now, in doing this process, there are 2 types of mistakes that you can make, okay? You can make what's called a type 1 or a type 2 error. Type 1 error, okay, is you could say something is significant when it's not. Conclude something is statistically significant when it is not. Okay, so that's one type of error you could make. You could say this thing is statistically significant when it's really not. Okay, that's type 1. A type 2 error would be just the opposite. You could say it's not significant when it really is. Both of these are bad errors, right? But there are 2 ways you can be wrong, okay? Right? You can make a type 1 error. You could say it is significant when it's really not. Type 2, you could say it's not significant when it really is. Okay. Now we're going to use the same chart we used last week. So I got some extra copies. Who needs the chart from last week?
Well, I would take some if I could.
You need another one? Is that the new one? G and Z. Yep. The one we used last week, yeah, this guy. Okay.
Lost in my papers here.
Okay, all right. Now, we've looked at every line on this table except one, okay? We've looked at every line on this table except one. At the bottom, we've got our confidence levels, right? Yeah? Nope, that's not it. There it is, okay. At the bottom, say for instance you want to be 80% confident, right? Then the critical value from the table for a Z, right, was 1.282, right?
Right.
If you had 10 observations, that would be a Z, that would be a T, and you go to what? You go to line 9. So you go up from 80% up to line 9, and the value from the table would be what? Okay, so we've looked at every line in the table. We've looked at this bottom line. We know what this column is, degrees of freedom. We've looked at every line except at the very top. Okay, very top. Okay, put your finger on 80% confident and go all the way up to the very top. What's that column called up there? What's at the very top of it? No, the number, the very top number. 0.10. Okay. If I'm 80% confident, how unconfident am I? 20%. But there's two types of mistakes I could make, right? Right? So if I'm 80% confident, I have 20% possible mistake or error, but I have to split that between the two types of errors I could make. So it's got a 10% probability of either one of these errors. Okay? We created an 80% interval, right? There's 20% outside, and there, right? So if I'm 80% confident, the probability I'm wrong is only 10%. Okay? You see why I did that? Because let's say I concluded it is significant, and it's really not. Then I only have to worry about one of these errors. If I concluded it is significant when it's really not, I've made this error. I haven't made this error because I said it was not significant. Okay, all right? So I've made one of those errors, one or the other. So if I'm 80% confident, I'm 20% wrong, but there were two possible errors. I've only made one error, a 10% error. Okay? Look at any one of those columns then. Look at, if I'm 60% confident, what's the probability I've made any type of error? Both types of error. 40%. So you divide that in half. What's the probability I've made one of those errors? 5%. So take the 60% and go to the very top of the column. What do you see up there? 0.20. This top line is called the acceptable error rate. Okay, the acceptable error. And most of the time when you're running a statistical test, okay, they won't tell you how confident they want you to be. They'll tell you how much error they accept. Okay? So the only difference in a confidence interval and a test statistic in terms of using the table is, are you starting from the top or the bottom? Okay? For a confidence interval, they'll say we want you to be 90% confident. For a test, they'd say we would have an acceptable error rate of what? Of 5%. And you look at the right? So if I told you, just to make sure we know how to use the table, suppose I wanted to run a test and I wanted a 25% acceptable error. And I have 50 observations. What value am I going to look at? Yeah, but what value from the table am I going to look at as my table value to see if I see?
The Z.
I'm going to use the Z on which column?
95.
No, on which column?
The first one.
The very first one. I want to be have only 25% acceptable error rate, which means 25, I'm going to get 50% confident. I'm in that first column. See, I could start from the top. You see, I could do the 0.25 from the top, right? And go down because I have 50 observations. I could use the 50 on there. I really couldn't use the 50 because I'd have to have 51 observations to use the 50. But remember I told you if it was over 30 observations, you use the what? The Z. Okay, all right, let's do another since I confused you on that one. I want a 10% error rate, okay, and I have 20 observations.
80%.
What is it? 10% acceptable error and
N minus one or N?
N minus 1,
Oh,
so
okay, then it'd be 1.328.
1.328. A 10% acceptable error, so you go across the top till you find what would be 10%, and then you go down to N minus 1, line 19.
Oh, okay, 1.3,
That-
okay.
Everybody got it? Okay, all right. Okay, one more, 5% acceptable error, and I have 12 observations.
796.
1.796, okay, everybody's got that. So that's how I'm gonna find this table value, okay? And so that last one we said was 1.796. If I come up with a calculated value that's bigger than that, what I'm observing is significant. If I come up with something that's not that big, then it is not that significant, okay? All right? So far so good? All we got left is do the formula then. So here's the formula.
That's for the calculated value?
If the calculated value is bigger than 1.796, it is statistically significant. If it's smaller, if I came up with a calculated value, say 1.1, it failed the test. It's not significant. Or at least I don't have enough evidence, okay? Here's my formula. It's going to either be a Z if I have more than 30 observations, or a T if I have less than 30 observations, okay? All right?
So it's a T if it's more and Z if it's less.
T if it's more than 30, Z if it's, and T if it's less than 30, excuse me,
That's right.
Z if it's more. Okay, we're going to take our sample mean, subtract out a target value. Okay. And yes, we'll tell you what these all mean in a second.
That's, it's supposed to be a symbol, correct?
Yep, this is a mean, this is a mu,
Okay.
a mu. Yes, it's a
Is that like
Greek
a
letter
U?
U, a baby U though, it's a baby U.
Okay.
Okay.
Oh, I thought it was an M.
I know, so
It's
that's
it is, it's a Greek baby letter, but we want it to be different from the mean. This is my target value. If you want to write target value, you can write target value. Okay.
Yeah.
Mean minus the target. And this is the standard deviation, right? And this is the number of observations. Okay? So far so good? Okay. So what I've got here on the top is the observed difference, okay? And what I've got on the bottom is the quality of the data and the quantity of the data. So what I've done is I've put that difference in the context of the data, okay? If I see a difference between my mean and my target value, but my data was all spread out all over the place, I should have seen a difference, right? That's not statistically significant because the data was junk, right? Or if I see a difference between my mean and my target and I had only a couple of observations, well, I really don't have enough information to say it's significant, right? So that's why those pieces are in there. They give us a context for this difference, okay? So here's my step, step 1. Take the mean minus the target value, whatever it is. The numerator, okay? Mean minus the target. Okay? Next, I'm going to do the bottom part. What do I have to start with the bottom part?
Square root.
Square root of n. So step number 2, take the square root of n. Okay. You guys know how to do that, right? We did that before. Step 3. Now I've got this guy. Okay. I need to take s divided by him. So divide the standard deviation by the answer to step 2. Okay. So divide the standard deviation by the answer to step 2. Okay. So this is verb again. Okay. Now, divide the standard deviation by the answer to step 2. Step 2 was this vertical, right? Okay, right.
She's meaning you have.
Yeah, step 3 is for twice.
Do I? That's because that's the new math. Didn't you know they put three's got favorable
Thank you for
status.
clarifying.
So four got expelled from the number table. Did you not know that? So if you were born on the 4th of July, forget it. You know, you don't have a birthday. Okay, what is step 4 then?
Divide by
Divide.
the answer to number.
Step 1, divide by the answer to step
Very good. Divide. You guys don't need me. Step 1 by the answer to step 2. Or step 3, excuse me. This one divided by that one. Okay? Now that I've done that in step 4, what do I have in step 4?
You have the calculator.
This is the calculated value. Okay. So what do I need to do with that?
Compare it against.
Compare it to the table. So step 5, compare to the table value. And on this one, the answers, you're going to calculate your value for me, and you're going to write down whatever you look up in the table, and then your answers are just going to be yes or no, pass or no pass. It's a pass-fail kind of thing, okay? All right? You don't have to write a big interpretation. You just have to say, yes, it passed, or no, it didn't. But you're going to have to write down. You need to. Part of what you get right can get right is showing me that you looked up the right table value. You know, when I gave you back your probability exam, some of you will look and see I wrote you looked up the number wrong, or you did some. So part of the points on the question assigned are for looking at the right value. Okay. Okay. Let's do a couple of examples, and that's from the t-test. You see these a lot. I mean, these are done in quality control. These are done a lot. I mean, that's what they'll run continually are these tests to see if they're missing their mark, to see if they're significantly different from their mark. If you're doing any kind of quality control in any kind of environment, this is what they're looking for. They're testing to see if what they're doing is hitting the mark, or if they're not, if the difference is statistically significant. If you're making a product, if you have a wait time for people calling into a call center, if you've got you're doing filing claims, and you see if this one's significantly different than others, to see if something's going up at a significant rate or going down at a significant rate. This is what they do all the time. And so you'll see these printed out on Excel spreadsheets and things like that. It'll give you usually it's quoted as a T, and it'll give you that T value. That T value is this value, this test statistic value. And then you have to take that and compare it to a value in the table to know whether or not it's significant. Okay, but they'll give you the calculated value. Okay, let's do an example. Let's do this example. Okay, we know what our mean is, right? It's 248. Our standard deviation over there was 2, right? And N was how much? 20 observations. Okay. So that's everything we need for the calculated value. So let's figure out the calculated value. Okay. What's my target? 250. That's what I wanted to have in the bottles.
Oh, okay. I was
Uh-huh.
confused.
Here we go. came up with a -5. Did I do that right?
Yes.
Yes, yes. Now, it's a negative number. Why is it negative?
Because 248 minus 250 was a negative number.
Because my mean is
Smaller than your.
smaller than my target. I'm below my target. So the negative sign just tells me I'm below my target, okay? But what I want to know is this difference statistically significant? To me, it's just as bad to have too few aspirin as too many, right? Right? So I care if it's significantly under or significant. I don't care. I don't care if it's under or over. I care if it's significantly different, right? That's what I care about, because too few aspirin is just as bad as too many. My table only has positive values, okay? So when I don't have, like in your Z tables in your book, you have positive and negative numbers. This would just have positive. So what I'm going to do is I'm going to ignore this negative sign. Because all I really care about is how far away it is, okay? It's like if you said to me, Susie, I'll take you to lunch. I already had a lunch with you, so. Anyway, but if you said that, I don't really care if we go north, south, east, or west. I just care how far away is it. Okay? How far do I have to go? Do I need to walk? Can I walk? Do I need to get in a car? Do I need a plane ticket? Right? Right? That's what I care about. How far away? Paris would be nice this time of year. Okay? Right? So, lunch and breakfast. Okay, right? So I just care how far away it is, right? This is the same kind of thing. I don't care. In this case, being under is just as bad as being over. Now, in some cases, that's not the case. In some cases, you really only care one direction, okay? For instance, in my weight loss example, I just want them to lose more than everybody else does. I don't care how much more. If they end up losing less than everybody else does, then I'm really upset, right? If people lose more weight just doing whatever they want to on their own versus using my diet, I'm in trouble, right? So I want to lose them to lose. So sometimes one direction matters. But in this case, the one direction doesn't matter. I don't care if it's underfilled or overfilled. I want it to have 250, okay? So I'm going to ignore the sign. Now, I need to go to my table and compare it to a table value, okay? Now, usually I will give you the level of acceptable error, but usually I give you both. I'll say, you know, this percentage confidence or acceptable error rate of this much. I usually try to give you both. But this is we're going to do this one the way your project is, okay? And in your project, I haven't given you acceptable error rate, okay? So what you have to do is you just have to look across the appropriate line in the table. For this problem, what's the appropriate line in the table? Line 19, right? Because there's 20 observations, so it's a T, so you have to go N minus 1, so you look across line 19. And just look across that line. Your calculated value of 5, remember we're ignoring the negative sign, is it bigger than the 0.688?
Yes.
Yes. 0.861.
Yes.
1.066.
Yes.
1.328, right? Keep going, keep going, keep going, keep going, keep going. It's bigger than all of them. Which means that this guy will pass or is statistically significant at the highest one. What's the highest rate there? 99.9% confident. That's an acceptable error rate of what? No, 0.0005. Which would be 5/10, no, 5/100, right? 1%. That's pretty accurate, right? What does that mean for me?
Good.
It's not good.
Oh, it's not good.
What do I have to do with my aspirin bottles?
Oh.
Go more.
I'm in trouble, right? I got a problem.
What's that sign? Is that a 2 or what is
This
that
is
sign?
an alpha.
What's that mean?
Acceptable error, okay? Acceptable error. Many times, if you look at it, if you've given a printout from Excel or something, like you're doing quality control work, they report the T, they'll give you an alpha say a 0.05 or an alpha of 0.01. That's the acceptable error rate. That's the error rate they will take. Okay. All right. Now in this case, my difference between my mean and my target is statistically significant at the highest level, with the highest level of confidence you can get. The lowest possible mistake you can make. Which means what? I can't sell these, right? It means if this is a real pharmaceutical company, it means they're going to dump all 200,000 bottles. If this is not a pharmaceutical company and this is something else that they're making, they're packaging lollipops or something, that means we're going to run a whole bunch of new labels and everybody's going to come to the cafeteria and we're going to relabel these to say 245 is what we're going to do, right? I've been in many, many situations where we ended up relabeling things because it wasn't that amount. It didn't work out that way. So that's what we would do in some cases. But if it's a pharmaceutical company, they will dump millions of units if they're off, even by just a little bit in quality control. They'll weigh the tablets, and if they don't have the amount of grains of whatever in they're supposed to have, and it's significantly, they'll dump all those out. If, like I said, if the bottle doesn't have the right number in it, they'll dump all those out. I mean, this is what quality control is about.
That's why medicine costs so much.
That's what sometimes why it does. But they, you're paying for 250. I mean, they've got to have truth. Plus, they want to make sure it's safe. Okay, so look at my numbers. My numbers look really good. 2 aspirin out of 250 doesn't look like very many. It doesn't look like it would be significant to me. But it turns out to be statistically significant because the 2 aspirin difference is the same as the standard deviation, right? Mm-hmm. And they have only 20 observations. So what I could do is I could take another sample. This is why people sample over and over and over and over and over again. They're trying to pump up the N. It's on the bottom. They'll bring the whole thing down. Or to get that standard deviation down, or somehow to get a refinement in the measurement. Because in this case, I have to dump these out. Okay, I've got a couple of examples. Let's do Coca-Cola bottle ones, and then we'll be done for today. Okay? Coca-Cola bottles. You know those 2-liter bottles? Mm-hmm. They're supposed to have 300 milliliters of pop in them. What's that?
Me.
No, they're supposed to have 300.
That's your N.
Get your target value. That's my target value. It's your U. Supposed to have 3. It's my Mew. That's right. Little cat like that. Mew. You ever go and look at those 2-liter bottles, and some of them are full, and some of them are not full, and some of them are like, whoa, you look through them to try to get the one that's got the most pop. You probably don't do that. We took a sample of 6 bottles.
Gonna have to do that next time.
And we found the mean was 284.3 milliliters. I told you they were underfilled.
Yeah,
Okay.
what is it?
The standard deviation is 1.5 milliliters. Okay.
Wait a minute, the mean is 284.3?
284.3, is that what I wrote down? Yeah, 284.3. So I want to know if this is a statistically significant difference. I want to be 98% confident. So what's my acceptable error rate? 0.01 or 1%, right? Right? Very good. Okay, run the test. What?
What's the units?
The what?
The degree of measurement?
I'm 98% confident.
Or the 300.
Milliliters. Milliliters. Okay.
Oh, okay.
All right. See if you can get this one. See if I get this one. Maybe I've done it already. Oops. Wrong steps. I'll do them in the other order.
Mm-hmm.
Yes, okay.
So on that homework, let's say we got negative, do you just want us to not even put the negative since we
You
not?
can put the negative down, but remember when you go to the table, you ignore it. Right.
That's the part I'm getting stuck at. So I'm gonna go to the.
Yes.
And.
It's the same column, right?
Yes.
Okay, but you're gonna go to line 5. There you go.
And why number 5?
Because you have to use
So do N minus 1.
the same 30 observations, right? You use N minus 1,
Okay.
just like last week, okay?
Okay.
All right?
So you're refreshed.
Okay, so what do you think? Are these bottles significantly underfilled?
Yes.
Yes, let's do a class action suit against Coca-Cola. Did you read the paper that lady was suing a company for 80 cents?
Wow.
Do we,
In New York?
are we ever gonna have one that's not significant?
Oh yeah, there are many times they are not significant, yes. Yes, it would just be if I had come up with a value of say
That'd be awesome.
2.974.
Super 80.
She was a coupon, one of those coupon cutting ladies, right? She had a coupon, she got $100 worth of stuff, and she had a $5 off coupon. So she returned some stuff, and they prorated her coupon, and she decided that they should have given her the $5 off, so she sued them for the difference, which was 80 cents.
So it's not,
What do you recommend?
It is statistically significant, because we came up with 25, we came up with 25.74, right?
right,
But the value from the table is only 3 something, okay?
okay.
So our value, if the calculated value is bigger, it is statistically significant. And I'll pass
Okay.
around one more thing and then we'll be done. Just for those of you who weren't taking notes.
How do we know the target value?
The target value, oh, that's the $150,000 question, you just ask it. If I had $150,000, I'd give it to you right now, okay? But you're not getting it. How do you find the target value for your project?
N minus 1, because we only have.
No, how do you find the target value for your project?
10.
No, how do you find the target value for your project?
We have no idea.
You have no idea. Okay, here's what you have to do. You have to find something that works in the context of your project. So what are some of your projects?
Cost for a trip to Jamaica.
Cost for a trip to Jamaica. Do you have a budget in mind of what you'd like to spend?
Sure.
That's your target value. And see if it's significantly more than your budget or significantly less than your budget, okay? What is somebody else doing?
Rushing yards of the Huskers.
What?
Rushing yards of the Huskers.
Rushing
Yeah.
yards of the Huskers whole team?
Yeah, I'm going to get the whole team. I actually
Okay.
started it, so I
Okay.
can get the whole team.
What should he use as his target value?
Anything more than
What's that, where are they gonna play in next year?
that. Big 10.
Big Ten. I'd find the average rushing yards of the Big Ten, is what I would do, and
Okay.
see how they're comparing to the average, right?
Okay.
So that would be the best one, I think, to use. You could use, if you have a really high season or a really low season, this is how we test if they're truly outliers. We see if they're significantly different from the mean. So if you have a really high value or a really low value, you can use that.
Okay.
What's somebody else?
Red lights.
Kills in a video game.
What?
Kills in a video game.
Kills in a video game and red lights. Okay,
Think
red
about
lights. What do you want your target value to be?
Because I'm small, I don't want to stop at them.
You want it to be what?
Lower.
0.
0.
But that's not a little.
0 is a legit. Sometimes 0 is a legitimate value. Okay. What did you said? Kills?
Kills in a video game.
You
Do
don't
you
want it
do you
either.
want to kill a lot of people or
Oh
not?
yeah, that's the point.
So satisfying.
So Do you have a really high value or a really low value, or are they all about the same?
They're about the same, 18, 20, roughly around there.
She's like, honey, where's my Okay, here's what I would do is if you, on that particular situation, I would either find another player and have them play once and see what their kills are, or play one more game and compare that as your target value, or see if you just make a significant number of kills and use 0. You probably do, but any one of those 3, okay? Okay, everybody kind of think, can you kind of think of a value for your project? Can you kind of, if you have trouble coming up with that target value, let me know and I can help you try to find that. Yeah.
Would a good target value be the desired number that you want, the best?
Yes, exactly. If you have a goal number, like she had an amount she wanted to spend on her vacation, she's going to compare to see if those vacations are costing significantly more than her budget or significantly less than her budget. Yeah.
Like my project is the number of minutes that a group of kids needs per week.
Yeah.
Sometimes they're sick, sometimes
Yeah.
they have other things going
Yeah.
on. So would it be like the perfect number?
Yeah,
Did they
exactly.
attend at 100%?
Did you hit your target or not? Yes,
Okay.
exactly. Okay.
Is next week your last meeting?
Next week is the last week we do material. We have a week after that, which will be do the final grades and stuff like that. So you'll come in next week and you do a test on test statistics, right? Then we'll talk about multivariate analysis, 2 variables. And so you'll have one more exam after that. It's a small one. It's like 10 points. But you will have that first week in March, we do have a class, okay? That Saturday, yes.
What if there's a test we want to retake?
You retake that at the end, yeah, we figure that out at the end. When we do the grades, we see if it'll make a difference in your overall grade, if it'll change your actual letter grade. And if it will make a difference, then we take it. Okay?
Funny.
All right? Ready to
It's
go?
real. Man, what did I do to this?
I'm gonna be here for a little bit, yes, I'm gonna. Okay, you're gonna come back, all right.
Drag me some lead somewhere.
Oh, no, it's fine.
You're gonna be so happy. I'm gonna have my project.
Okay, so this is. Remember, this is only the first of Then, for this one, for the 80 and 99, you'll go to those for day. Yeah, okay?
So how do we do this table thing with the 2, or it's which part of it that we learned today? That we
Okay, it's if you're,
compare the whole entire row of numbers.
oh, today, if we, the first example, I didn't give you a acceptable error rate. We came up with a 5 for our calculated value. We had 20 observations, so we went to line 19, and we just looked across line 19.
I got you.
And we're bigger than all of them.
And
So-
and what number were you trying to compare it to?
That 5 that we calculated, our calculated value,
ours. Okay.
this
Yeah.
value that we came up with.
He's already on the way.
Okay, so we're comparing our value in step 4 with the table value, okay? And we're looking
Yeah.
across that line.
So our 5 is negative though, right?
Yes, but we don't have a negative table, so we have to just ignore that negative sign, okay? If we had the negative side of the table, we could use that, but since we don't only have positive numbers, everything's an absolute value, okay? So we're gonna say it's bigger than all of those, so it is significant even at the highest level. I can be 99%, 99.9% sure this is significant.
You said
Okay.
that it's bigger than all of them.
Mhm.
I thought you said it was small, and I was like,
Hello.
how is that?
Okay, we need to plan what we're gonna do.
I guess you
What
can.
we're gonna do.
Okay, so you got
Right here.
Okay.
those
Okay.
are the questions.
You've got,
You did that. You had all
your
of
standard deviation, I just looked at left and right.
I
We
missed
did
the,
that.
when I just added the square root and I
But then you were supposed to write the 100 words.
Okay, okay, so did you know what you did?
Yeah, I tried to show like.
Yeah, you'll have to do that one again, okay? So you need to set a time to come in and just do that again, okay?
So on that page
Then you need profitability, and you need to do confidence intervals.
Yeah,
This last one, okay, so you need to do, so you've got those three you need to do, so what else, what do you want to do?
Mine periodically.
Okay.
This is, that's
Okay. Okay. I'm not here on Monday, and I usually have meetings in Green on Tuesday, but I am here Wednesday, Thursday, and Friday. And I'm here, I'm usually here by 2 o'clock in the afternoon. Sometimes I'm here all day, but I'm always here by 2 o'clock in the afternoon, so I'm here from 2 to 6. Those days, Wednesday, Thursday, Friday. Okay, bye. And what we'll do is we'll let you start with the sanitation, do that one, then I'll give you the notes. I do have, I can bring you DVDs of the class now, because we've been doing that. So I can give you the class and, give you the notes and the DVD, and you can look at that, see what you think.
Yeah, she hasn't talked very well.
Yeah, some catching up to do, okay? All right?
Do you have the notes now?
The notes,
the assignment?
yeah, I want you though to make sure you focus on getting the sanitation right, okay? Okay?
I get it. When I after I handed it in and I looked at it to see if I did it right, I was like, oh.
You know, you can use your notes, right? You knew that you could, yeah, you can use your notes now. You couldn't, yeah, you can use your notes. Ever since the first exam, we couldn't use our notes, but every exam after that, so there's target probability.
I got what we need, but it's
Another thing for probability. Oh, that's mine. I'll give you this one. That's all right. Well, I tried marked on it. Okay, and then you need, this is the homework for probability. Oh, that's mine again. That's what I make copies off of, so that's the master, okay. And then, I think I'll have to make you.
I can just get it on tape.
Okay, the confidence interval, and I think I just have the masters here, I'll have to make a copy of it, okay?
So Tuesday.
Wednesday,
Sorry,
Wednesday, Thursday, or Friday after 2, yes, okay?
All right, I'll email you and let you know.
Okay, all right, great.
Thank you.
Yep.
The Saturday, March 5th that we need. Next week, can I just get like the stuff that we would cover in that class, and then I'll come like Wednesday before that Saturday and do that test or something? Okay. And we're just going to do the class test. We're not going to have the science, right?
No, just to finish your project, people haven't finished their project, and retakes if there's any retakes.
Okay.
Okay.
Because I'll hand in my project.
Okay, okay.
Okay.
Yeah, then the final topic we do, some classes will get to it, some classes don't, depends on how fast we move, if we have holidays and stuff like that. But it's a topic on, it has to do with two-variable analysis, which is a little advanced for us, but I like to kind of throw it in just to give you a chance. So that's what it's on. Okay. And I think it's only that test and then the time points.
Well, we'll talk about that next week, right? So,
Yeah.
so then that'll be fine. I'll just
Yeah.
get the test a little earlier than.
Yeah, okay. All right, thank you. Hey, you got that for you?
I probably did this wrong on a test too, because there was a number.
All right, so you live out by Highway 2?
Yeah, for you.
Okay. Yeah, you're done this year.
Yeah.
If you're gonna round it, you round up.
See you, Rocky.
Bye.
Bye.
Have a good day.
You too.
Bye.
See ya.
Okay, so this would be 6.6. Hey. Hi. Are you want to do your test? Yeah? Okay. Okay, let me get the test for you, and then we'll check your homework too.
No, the average of the test that they took was 630. That would be their mean. The target value was the overall average of 500.
I asked that too.
But the mean is 630, and the target value is
500. Yeah, that's the overall average for what you want to beat. Is that what I think?
Okay. Well, it usually, it depends on what I was given. For instance, here, since I was given 410, I went in my calculations to 3 decimals. I always go one more than what I'm given. But if it's just rounding, I can find that. That's what I'm looking for is to see, did you look at this number right? Did you know square root of this, s divided by that? Okay, that's what I'm looking for, okay? Yeah, okay, good. Okay, here's the same. You don't do that if you're doing your project, you're not doing it. Okay, you got it. All right, good deal. What? 8.4, yes.
If the end isn't on here.
Yeah, but if it's over 30 observations, what do you do? There's a Z, remember? That's why these say normal, because they're using the Z. So the first three are going to use the Z.
We're going back to the last one.
Yeah.
And
It doesn't matter.
yeah,
No.
Shoot.